Hi guys, welcome to the unit on the Pythagorean Theorem. We are first going to talk about what the Pythagorean Theorem actually is, and then we will use this little tiny sheet of paper and do two examples on it. So hopefully this should be a quick summary video. You've already talked about the Pythagorean Theorem. It deals with right triangles. So I'm not going to write on this side of the page because it's just hard to write on. So I'm going to leave my notebook flat open. And we're going to say the Pythagorean Theorem. Okay? And it's for what kind of triangles only? For right triangles. So it has to have that 90-degree angle. For right triangles only. Okay? So we've got maybe a right triangle that looks like this. Remember, it has that 90-degree angle. Or maybe our right triangle looks like this. So the 90-degree angle is up here. Or maybe we have one that looks like this. Okay? And the 90-degree angle is over there. And so remember, the formula is a squared plus b squared equals c squared. Okay? Now remember, A and B are the legs. Whoops, that's the worst N I've ever written in my life. A and B are legs. And C is the hypotenuse. C is the hypotenuse. Okay? And so we use the Pythagorean theorem to find missing lengths. Well, in order to do that, the first thing we need to know is where A, B, and C are. So, really easy. What you're going to do is A and B are the legs, so they're going to be the ones that are connected to the 90-degree angle. And C is the hypotenuse, so it's always going to be across from the 90-degree angle. Okay? So here's the 90-degree angle, right here. So if I draw an arrow, this is C. Okay? If I draw an arrow, here's the 90-degree angle, draw an arrow, that is C. Here's my 90-degree angle, draw an arrow, that is C. Okay, so it's going to be the diagonal looking one. Okay? And then A and B are always going to be the other two. Okay? Does it matter which one's A and which one's B? No. Okay, you decide which one's going to be A and which one's going to be B. Okay, we could flip-flop them and it would be totally fine. Okay? Alright, so let's do a few examples about the Pythagorean theorem. So you're going to need this little foldable here. Go ahead and fold it in so that it touches this line right here. Okay, so I took this side, I folded it in so it touches this line. And then I'm going to take this side and fold it in so that it touches this line. Okay? And then on the outside here, we're going to draw a right triangle. So this is my right angle. So C is over here, and then A and B. So if the part that you're missing is a leg, then you're going to have an X on this one or this one. That's what a leg is. Okay, so if you're missing a leg, you're going to use the formula, but it's going to be used a little bit differently than if you're missing the hypotenuse. So here's our triangle again. There's C, A, and B. So for this one over here, the part you're missing is the hypotenuse. Okay? So up until this point, we have used a model. Okay? I haven't made you use the formula. But we're going to use the formula in this booklet. Okay? So here we go. Step 1. Write down the formula. So the formula is a squared plus b squared equals c squared. I did not substitute any numbers in. Okay? Step 2. Find A, B, and C. So remember, C is the number across from the right angle, and then these are A and B. Okay? Alright, so I know what A, B, and C are. So step 3, substitute A, B, and C. So A is x, so we'll say x squared. B is 8, so we'll say 8 squared. And C is 10, so we'll say 10 squared. Okay? Step 4. You're going to square everything, so square all the constants. So, hold on a second. So we'll call that simplify the exponents. Okay? So we can't do this one because we don't know what x is, so we'll just rewrite it, x squared. We can do this one, 8 squared is 64. And we can do this one, 10 squared is 100. Step 5, you're going to subtract. So we subtract 64 from both sides. So we're left with x squared equals 100 minus 64. That's 36. And then you're going to take the square root of both sides. You can't take the square root of just one side. You have to take the square root of both sides. Okay? So, the square root, the last thing you're going to do is simplify. So the square root of x squared is x, and the square root of 36 is 6. Okay? Now simplify, you might need to do the cake method or whatever. Okay? So just keep that in mind. Alright. Next up, if the missing side is the hypotenuse. So here we have our problem. So it starts off the same way. Step 1, we're going to write the formula. So it's a squared plus b squared equals c squared. Step 2, we're going to find a, b, and c. So across from the right angle is c, and then the other two can be whatever you want. Okay, you pick. I picked A was 15, but it could have been B. I don't know. Step 3, you're going to substitute A, B, and C. So A is 15, so 15 squared. B is 18, so 18 squared. C is x, so x squared. Step 4, you're going to simplify exponents, remember? So 15 squared is 225, 18 squared is 324, and we can't simplify x squared. So what do you think we do next? This time we're going to add. 225 plus 324 is 549. Next, we're going to take the square root of both sides. So that's where you go square root of 549 and square root of x squared. Last, you're going to simplify the radical. Okay? So x squared becomes x, and then 549 is what I'm taking the square root of. So I'm going to go ahead and try to find the prime factorization of 549. So let's see, 549, I'm going to start by dividing by 3 since it's not even. It comes out even, so here we go. 549 divided by 3 is 183. Now it's not even again, so I'm going to go ahead and try to divide by 3. I get 61. 61, is that a number on my list of radicals? Of prime numbers? Actually, if you look, it is on my list of prime numbers. So I am done with my my cake. Just need to finish dividing that 61. So I can pull out a 3 as a simplification of 549. So this is 3 square root of 61. So sometimes you need to make sure you simplify the radical. Okay? Alright, so this is going to get glued in underneath the notes we just took, which are here. So go ahead and glue these down right here, and you're good to go. Thanks for watching, and have a good day.